Okay, today we're starting Unit 5, and it's all about polynomials. Now, we're not going to hit every single thing in the polynomials unit. We're just going to kind of skim it, take out some important pieces and some important information that can help you on the ACT. So we're kind of switching gears from this point on. We might not do many more full units, but we're going to hit as much different information as we can to get you ready for the ACT. So today we're going to look at Lesson 13, and your I can statement or learning objective is I can simplify and classify polynomials. Now, I know that you've seen this before. You saw it in Algebra 1. I remember specifically, if you had me, our notes today are going to be very similar to those notes that you did back a couple of years ago, but we're going to talk about simplifying and classifying polynomials by degrees and terms today. And as always, I'm going to be moving faster in the video than I would be in person, so feel free to pause, rewind, watch it at your own pace, do what you need to do. I do ask that you take these notes and do the examples with me so that you can use those when you do your Math Excel work in just a little bit. Okay, and if you have any questions or need any help at the end of the video, you're welcome to hop back in the Google Meet or hit Ask My Instructor, or send me an email, or whatever you need to do. Okay, first we're going to start off with some vocabulary. First, we need to know what a polynomial is. So a polynomial is a monomial or sum of monomials. Now we're going to talk more about a monomial later, and I hate that when the book uses a term in the definition of another term. But that's what we're going to go with. Hopefully, since this is not brand new information, it won't be too confusing. So a polynomial can be just a regular monomial, which means one term. So like x is considered a polynomial, 4x cubed, all of those are monomials because there's just one term, but they're also considered polynomials. You can mix them up, like 3x minus 6, that's 2 monomials. You have 4x squared minus 3x plus 8, that's 3 monomials put together. So each of those is considered a polynomial. So that's what we're going to be looking at today. Okay, next we need to talk about the term of a polynomial, and we'll just refer to them as terms. But you do have to be specific when looking at the actual definition because we are talking about polynomials. So the term of a polynomial is separated by plus or minus signs. So, like if you look back up here at these examples, here are 2 terms, okay, separated by that minus sign. Here are 3, separated by the minus and the plus, okay. So 1 term, 1 term, 1 term, 2 terms, 3 terms, and you can keep going on and on. The exponent of each term is that term's degree. And we're going to talk about degrees a little bit more in just a second, and we're going to talk about the degree of a polynomial. When you hear me ask for the degree, or Math Excel asks you for the degree, it's going to be asking for the degree of the polynomial, not of the term. But it is important to know that each term does have its own degree. Okay, now this is what I was referring to just a second ago. The degree of a polynomial is the highest exponent among all the terms. So you look at the polynomial, you find the highest exponent, and that's the degree of the polynomial. So if we look back up at our examples here, this one, the highest exponent is 3, so the degree is 3. Here, the highest exponent is an understood 1, so the degree is 1. Here, the highest exponent is 2, so that has a degree of 2. Okay, and we'll practice classifying by degrees and terms in just a little bit. Okay, before we move on, we do need to, again, talk about solutions, x-intercepts, roots, and zeros. When we talked about quadratics, I think we made a note that all of those are kind of interchangeable. Same is true with polynomials. Sometimes you'll hear, we'll talk about solving a polynomial, finding the x-intercepts, the roots, the zeros. Now, roots and zeros are more common with polynomials. With quadratics, we use solutions and x-intercepts, but roots and zeros are more common to talking about polynomials. And it's important to note that if it's asking for real zeros, then those are the x-intercepts on the graph. So if you graph the polynomial on a coordinate plane and it hits the x-axis, those intercepts are the real zeros or real solutions. Okay, the last definition we're going to talk about is the standard form of a polynomial. again, we have to be specific. We're not just saying standard form. We're saying the standard form of a polynomial, because if you remember back when we were doing quadratics, and then way back at the beginning of the year when we were doing systems of equations, we had a standard form, and those standard forms are different than the standard form of a polynomial. So you get the standard form of a polynomial. After all the like terms are combined, the polynomial is written with degrees in decreasing order. Okay, so, and here's an example, and I put some dots at the beginning because we could start with whatever degree we wanted to. I just started with 6 just so you could see, but we have 6, 5, 4, 3, 2. This is an understood 1, and this is a degree of 0 because it doesn't have a variable. Okay, so after you combine like terms of a polynomial, you always want to get it in standard form. You want the degrees in decreasing order. That makes it really easy to find the leading coefficient, the leading term, and the polynomial's degree. And we'll do that in a little bit. Okay, and before we move on to some examples, I just wanted to give you a little visual here to help you identify important pieces of the polynomial. So I just wrote down a sample polynomial, 3x fourth minus 6x squared plus 5x minus 8. Okay, this first term, 3x to the fourth, is the leading term. The 3 is our leading coefficient, or a, and then the 4 is our degree. So when you look at a polynomial, you need to be able to find those 3 things. So that first term is the leading term, that first number is the leading coefficient, and that exponent is the degree. As long as it's written in standard form, you can pick those out very, very easily. Okay, now we're going to work on some examples. And you can see I've already written examples 1 and 2. We're going to work through those. And what we're going to do is we're going to classify, we're going to simplify them and put them in standard form. Then we're going to classify them. Actually, I take that back. Hold on just 1 second. I just realized that we were about to do examples and I haven't even told you how to classify yet. So mark that out, erase it, and we'll start over there. Okay, now let's talk about classifying. Polynomials can be classified by terms and or their degree. Or maybe I should have said degree and or terms. Okay, so each polynomial can have 2 names. One name comes from the degree, and then the other one comes from the terms. So remember, the degree is the highest exponent. If it's a degree of 0, it's constant. 1 is linear, 2 is quadratic, 3 is cubic, 4 is quartic, 5 is quintic, and 6 or more, you say the 6th degree, 7th degree, 8th degree, so on and so forth. So let me show you an example of what that degree would look like. So if you have a constant, a degree of 0, you just have some number, okay? If it's linear, it's just an x. There's an understood exponent of 1. Okay, quadratic is an exponent of 2. Cubic is exponent of 3. You can think of cubic. A cube has 3 dimensions. Quartic is 4. And so an easy way to remember that is 4 quarts in a gallon, or 4 quarters in a dollar, or 4 quarters of an hour. That might help a little bit because quartic and quadratic are often confused. Quintic is 5, and then everything after that. So x to the 6th, x to the 7th, x to the 8th, so on and so forth. Okay. Then you can name them by term. So that's the number of pieces separated by plus and minus signs. So 1 is a monomial, 2 is a binomial, 3 is trinomial, 4 or more, you just say a polynomial with that number of terms. Okay. So these are usually pretty easy to remember because the prefix mono means 1, bi means 2, like bicycle, tricycle is 3, and then 4 or more, we don't have a special name. So I can show you a little example. So 3x is a monomial, 4x minus 8 is a binomial, x squared plus x minus 9 is a trinomial, and then x to the 4th minus x cubed plus x minus 9. That's a polynomial with 4 terms, okay? And you could do 5, 6, 7, whatever you want. So we're going to practice doing some examples, okay? Really, we're going to do some examples this time. And we're going to practice combining like terms, putting the polynomial in standard form, and then classifying it by degree and terms. And then we're also going to practice picking out the leading coefficient and leading term, okay? Just because you're going to be asked all of those different things on Math Excel. Okay, let's look at these examples. We're going to start with example number 1. We have negative 4x squared. So first we need to check and see if it's in standard form. That's the only term, so yep, it's good. There's nothing to simplify or combine. Okay, so now we're gonna name it by degree. So our highest exponent is 2, so that is quadratic. So we're gonna say this is a quadratic, and it has one term, so that's a monomial. So quadratic monomial. Okay, we're gonna go ahead and practice this next part, and because you will be asked in Math Excel. All right, so the leading term is this. It's the only one we've got. So the leading term is just negative 4x squared. The leading coefficient is negative 4. Okay, and then it may ask you to identify the degree, but we already found the degree. We know that it's 2 because we named it a quadratic. Okay, so on Math Excel, you just have to pay attention to what the problem's asking. It may just ask you to name it. It may ask you to name it and find these things, or it may just ask you to find the leading term, leading coefficient, and degree. Okay, but either way, as we practice all of it together, it'll make it easier for you when you practice on your own. So number 2, we have 5x cubed minus 8x cubed plus x cubed. So first we need to see if we can simplify. All of these have x cubed, so that means that we can simplify. So 5 minus 8 is negative 3, plus 1 is negative 2. So negative 2x cubed. Okay, so we simplified. Now we just have a monomial, so it's in standard form. We're good there. Okay, we find the degree, so the degree is 3. So we call that a cubic. Again, it's just one term, so cubic monomial. The leading term is negative 2x cubed. The leading coefficient is negative 2. Okay, and again, we simplified, made sure it was in standard form, named it by degree and terms, and then we're just pointing out the leading term and the leading coefficient. Okay, here's example number 3. We have 6x cubed minus 6 plus 4x squared. So first we need to see if we can simplify. We have an x cubed, no x, and x squared. So there's nothing to combine here, so we can skip that. Now, is it in standard form? We have 3, 0, and 2. So that's not in order. So we're going to have 6x cubed plus 4x squared minus 6. And make sure when you're writing it in the correct order, you take the number and the sign, okay, or that sign in front of the term. All right, so now that it's in order, our degree is 3. So this is a cubic. We have 1, 2, 3 terms, so a cubic trinomial. The leading term is 6x cubed because that's what's in front. And that leading coefficient is 6. Okay, and I'm just abbreviating so I don't have to write out those words every time. Okay, but Math Excel, it'll say what's the leading coefficient. Number 4, we have 8x minus 7. So we can't simplify anything. It's already in standard form because we have 1 and 0 for our terms, our degree of our terms. All right, so now we need our overall degree. Our highest exponent is 1, so that means this is linear. There are 2 parts, so it's a binomial. And our leading term is 8x. Our leading coefficient is 8. Okay, and then again, our degree is 1. Okay, number 5, we have x to the 7th plus 5. So it's already in order. All right, so our degree is 7. So that's a 7th degree polynomial, or not polynomial, sorry, seventh degree. There are two terms, so it's a seventh degree binomial. Okay, and I'm just abbreviating because I'm running out of room here. Okay, the leading coefficient or leading term is x to the seventh, and the leading coefficient, we don't see one, it's an understood 1. Okay, and our last one, number 6, we're going to squeeze it down here at the bottom. You're just given a 10. So there's nothing to combine. There's only one term, so it's already in order. So there's no x, so that means our degree is 0. So this is a constant. Okay, there's only one term, so it's a monomial. And so the degree is 0 here. It's a constant monomial. The leading term is 10. There is no leading coefficient because there is no variable, so that's just a plain old 10. Okay, and I think you do have at least one like this in Math Excel, and you just have to label it by degree and term. Okay. So as I look over your Math Excel assignment, most of the examples really come from what we did here. So it might be worded different, it might have things mixed up a little, but you're still finding all these different pieces of information. Just pay attention to what the question's asking. It may just want the name, quadratic monomial. It may just want you to tell what the degree is, that highest exponent. Or it may ask you for lots of the other information like the leading term and leading coefficient and all that. But if you look at your notes, if you write these down, you have your chart, you look at these examples, you should get through the assignment pretty easily. But if you need help or have any questions, please don't hesitate to ask. I would be happy to assist you however you need. Okay? Have a great rest of your day.